Hi, this is Mrs. Rose here. Little installment on how to do dimensional analysis in chemistry. This is a very valuable problem-solving tool that we will use again and again in this class. And the idea is it is a tool to help you with problem solving in an area where you may not fully understand the concept. So we're going to start with an area that you should understand, and that is the metric system, and then we'll proceed on to other areas later on as the year progresses. But basically, you all know that in math, anytime you take a value, any number, and multiply it by 1, you don't change the value of that number. Well, that's the principle behind dimensional analysis. All we're doing is multiplying by 1. If you take a number and you multiply it by 1, or a ratio that actually equals 1, then you haven't changed the value of the number, and that's how we're going to solve dimensional analysis problems for unit conversions. So here's our first example. So we have this problem in front of us that says, what is the mass in grams? And we're given actually 359 milligrams. So first of all, identifying your given 359 milligrams of a substance. Okay? So the first step in doing dimensional analysis is the technique is actually to orient the units so we know what is in the numerator and what is in the denominator. So what we're always going to do is take our given and put it over the number 1. So for this problem, since our given is 359 milligrams, I'm going to write 359 milligrams over 1. That's the first step. The other thing we want to do is recognize where we're going, where we're heading in the problem. And where we're heading in this problem is that we are going to grams. That's our destination, grams. So in essence, what we're doing in this problem is going from milligrams to grams. So now we know where we're starting, where we're ending, and we're going to solve this problem very simply by looking at the next step. And the next step, I'm going to write over again my given over 1, 359 milligrams over 1, just so it's in the proper spot. I'm going to multiply by a ratio, and this ratio that I'm going to use is a ratio that will equal 1. In other words, the value that goes in the top will equal the value that goes in the bottom. And you might say, well, wouldn't that be 1 over 1? No, we're going to choose 2 different units. And the units that we choose will come from our metric conversion that we were looking at earlier, milligrams and grams, that conversion. Since we're multiplying, and remember this is the key, this is multiplied by, we're multiplying 359 milligrams by a ratio that equals 1. Okay, then what we want to do, take some of that clutter away, we're going to put the units in the bottom that we want to cancel, milligrams. That's where we're beginning. And what we want to end up with, what goes in the numerator, will be the units where we're heading. In this case, we're heading to grams. So the value on the bottom and the value on the top, we have to go back to the table, if we don't have it memorized yet, for metric conversions. And the conversion factor is between milli and the base unit of grams. So if you look at that, the milli and the base unit of grams, 10 to the minus 3. What does that mean? It means that 1 milligram is equal to 10 to the minus 3 grams. Now we have a ratio, this one right here, that equals 1. 10 to the minus 3 grams is exactly equal to 1 milligram. So this ratio right here exactly equals 1. I'm going to multiply, and in doing so, my units here will cancel. 359 times 10 to the minus 3. If I do the math there, I end up with 0.359, and now the only unit that is left is grams. So I've taken the given over 1, multiplied by a ratio that equals 1, and now I have the answer. Let's try it again. We have a new problem. It says calculate the volume of a 2-liter soda bottle, but convert it into milliliters. So we know right off the bat our given is 2.0 liters. And we know that where we're heading, we're going from liters to milliliters. That kind of gives us an idea of what we're going to do. It's always good to have a problem where you know where you're starting and where you're ending. That's a good life lesson. All right, so pause the podcast for a minute. See if you can do this problem using dimensional analysis on your own, and then start it back up again, and I'll work it out for you. All right, so we take our given, and we put it over 1. So in this case, my given is 2.0 liters. Put that value over 1. Second step, we multiply by a ratio that equals 1. So since I'm comparing liters to milliliters, those are the 2 units that I'm going to put in this ratio. And since liters is going to cancel liters up here, I want to be sure that my liters in this ratio goes in the denominator, and my milliliters, where I'm going to end up, goes in the numerator. Now I go back to the table, and I see that we just did this. 1 milliliter equals 10 to the minus 3 liters. So I put 1 milliliter, the number 1 goes with the value that has the prefix. 1 milliliter equals 10 to the minus 3 liters. Now in this case, notice that that exponent is in the denominator. When we go and cancel our units, liters, we'll cancel liters, and we'll end up dividing by 10 to the minus 3. When we do that, change the sign, and we end up with an answer that is 10 to the positive 3 milliliters. You might write that as 2,000 milliliters. Second example. Third example, we're going to take it another step, a little bit more complicated in this case. This one, now notice there are squared units. You might have some homework problems where you have to use cubed units, but the same concept applies. If you have an idea, give it a try. Pause the podcast and try to do the work. Hopefully you already know what is your given and where you want to go. So our given is 25 centimeters squared over 1. Notice we put the given over 1, not over 1 meter, not over anything other than the number 1, just to make it a ratio. We're going to multiply by a ratio. Well, if you notice, the metric conversion doesn't show anything about squared units, but we do know something. We know that 1 centimeter equals 1 times 10 to the minus 2 meters. We do know that. So we can use this conversion factor in our ratio. But notice 1 centimeter, 10 to the minus 2 meters, that will only cancel out 1 of the centimeters squared. So what I have to do is a second time. So now in the denominator, I have centimeters squared, and that will cancel out the numerator, centimeters squared. Centimeters squared, centimeters squared. Do the math, and we have, oh boy, 0.00, let's see if I've got this right, 25 meters squared. Is that right? Let's double check. That'd be 10 to the minus 4. And if I'm doing this math in my head, I'm going to end up moving at 1, 2, 3, 4. Yep, check. Final answer. If we were going cubed, yes, you guessed it, there'd be one more step. Hope this helps you with your homework this evening. Have a good night.